Sir, please.
Yeah. I have to share my screen, so just give me a couple of seconds.
Sure, sir.
Can you see my screen?
Yes, sir, we can.
Thank you. Okay, assalamu alaikum. Welcome everyone to this today's session. This is Dr. Abdul Motin with you. And first of all, I would like to thank the organizers and especially IICT RUET for giving me that floor to share my thoughts, my expertise with you guys. I do believe it will be interesting and it will be interactive. So if you have any query or if you have any questions, you can write in the comment box. And I do believe the co-host, they will help me to read those text, or directly you can unmute yourself and share your question. So rather than going to broadcasting approach, I always prefer interactive session. So during my talk, you are most welcome to stop me, to hold me, and if you have any query, if you have any questions, feel free to ask me, it will be a brainstorming session. So it will be more interactive. Today's talk, I'm going to presenting on biosignal processing, basically for healthcare application using Python. So this is the outline of today's talk. So I will briefly overview about the importance of signal processing, why we need to learn signal processing, and then I will narrow down the topic into biosignal processing in healthcare. I will try to focus the signal processing approaches, the challenges that we normally face in biosignal processing for healthcare application, and then as a computational platform, I will give you a very brief overview about Python, how we can use Python to solve those problems for classical signal processing and the biosignal processing problems. And then I will give you a bit overview about time frequency analysis technique for solving biosignal processing problem, and then signal processing, pre-processing, and feature extraction. A bit about biosignal processing for machine learning and future direction, for like in which direction we can work, and why we can apply our expertise, or how we can apply our knowledge to solve a real life problem. So application of signal processing. Signal processing is very diverse field, very diverse. So, and signals are everywhere. So if you think about its application, it's extremely diverse field, from control to communication, from robotics to automation. Everywhere you can apply signal processing. Like in modern like surveillance system, modern system detection, video monitoring, video surveillance, structural health monitoring, speech signal processing, and so on and so forth. But the good thing is that you don't need to be expert on, or you don't need to be a core signal processing engineer to work with signals. But if you have fundamental knowledge on signal processing, or if you have advanced knowledge on signal processing, that will help you to move further your project. So the good thing is that if you have a solid knowledge on signal processing, or if you have a solid knowledge on advanced signal processing, that will help you to rethink your project in different dimension. So if you think in that perspective, yes, signal processing can play a vital role in your project. And for those who are working on signal processing, or working on machine learning or biosignal processing, for those, yes, it's a very important tool, important topic. and a lot more to discover, and a lot more area to work. It's a fascinating area to work, and I do believe most of you have fundamental knowledge or few ideas about signal processing and classical signal processing. So I would like to narrow down my topic on biosignal processing or signal processing in healthcare. So if we talk about signal processing in healthcare, then this is the the workflow diagram. Like we are engineer, definitely. We are not a doctor or a physiologist. So we have a different working style and different expertise. So for healthcare application, basically we need biosignals or physiological signals, definitely that come from patients. And then this is the area where we have to work. That means we have the biosignals or physiological signals, or it may be wearables, some sorts of physiological signals that is collected from the patient. And then we need to process the data. We need to analyze the data. We need to learn from the data, and then we have to make a decision. So this is the conventional work procedure as a signal processing engineer or as a machine learning engineer. So this is the workflow. And if we think about the application, mainly we apply signal processing for patient monitoring. In critical care, it may be ICU or neonatal care unit, coma. Sometimes we can apply signal processing for real-time monitoring. And definitely, if we talk about biomarkers, then we have to work on biomarker detection, like vital sign monitoring, and this is one of the very emerging field and emerging application of signal processing, because in today's life we can think without wearables. Wearables is everywhere, and most of the people they're using a smartphone or mobile phone. So that domain is very emerging, and lots of research is going in that direction. And another important application of signal processing is preventive healthcare. Like we try to predict the disease trajectory, trajectory in the sense we are predicting the health condition from a previous information, previous data. So this is one of the fascinating domain or area of research. And then human-machine interfacing and rehabilitation engineering. So most of us heard about bionic eye, bionic ear, prosthetic organs. So it's a area of where we can work. And another important aspect of signal processing is that sometimes we don't know the physiology or don't know the reason of the disease, why that disease has happened. So sometimes we can apply signal processing to go deeply and towards a disease or towards the physiology to understand more vivid way, more clear way. So that might be another application. So this is the very few application that I have mentioned, but without this list of application, there's a many more application where you can apply your signal processing knowledge in healthcare. So now I'll talk about the challenges that normally as a signal processing engineer or a signal processing researcher we face. If you think about physiological signal or biomedical signal, the main problem of biomedical signals or physiological signals that they can easily be corrupted, and they can be corrupted in different way. Due to environmental noise, it can be corrupted. Due to system noise, it can be corrupted. Sometimes you are measuring one physiological signal that can be corrupted by another physiological signal. For an example, I can say like that, let's say we're collecting cardiac information, and simultaneously we're also collecting the respiratory information. So there is a chance that your cardiac signal can be affected by your respiratory signal. So like physiological signal can be corrupted by another physiological signal. So noise is a very common problem in analyzing the physiological signal. And another problem is that sometimes, most of the cases, the classical signal processing techniques fails to estimate or fails to, you can't fit all the classical signal processing problem like approaches to solve your problem. So that means you need something more. You need to apply some state-of-the-art approach to solve your problem. And another challenge is that we need a system, automated system, but the problem of an automated system is that most of the cases that's not reliable. So I know if you use the heart rate using apps, 10 different apps in your smartphone, you will get 10 different measurement. That means the system is automated, but that's not reliable. So we need a system that is automated um, and reliable. So if you think about biomedical perspective, we need a reliable system. So if you have a system, but that's not reliable, so that will not be we can't use that automated system in a patient related or medical graded application. And another challenge is that we need a faster tools, and we need a model that easily implementable. So we have to have a faster and easy to use model that can easily implement in the system. And another thing is that if we want to make a decision, then we need to extract the biomarkers. But biomarkers extracted from the noisy signal that can mislead your diagnosis, that can lead to false diagnosis. So these are the common challenges if we think about biomedical perspective. And so how we can solve those problems? So like in which direction we can walk to solve this problem? Excuse me. So as I told earlier, that if you use a classical signal processing technique, then it will be really hard to handle a nonlinear and non-stationary problem. That means you have to apply some advanced technique, advanced spectrotemporal approaches. So let's say for denoising, if you use simple filter or simple filtering approach, most of the cases your classical filtering approach will fail to denoise your signal. That means we have to apply some adaptive filtering, or you have to use some Bayesian filtering with prior input. And there are a couple of examples of Bayesian filtering that are like you can use Wiener filtering, you can use recursive Wiener filtering, you can use Kalman filtering, and extended Kalman filtering. And if you think that your signal is highly non-Gaussian and non-stationary, then based on the distribution of your distribution of the data or distribution of your problem, then you have to choose what type of Bayesian approach you have to pick to solve the problem. Just a simple example, let's say you have a problem where the data is highly linear, then definitely Wiener filtering will give you the best solution. But the problem is that Wiener will give you the best solution, but most of the cases Wiener will fail because most of the problem is nonlinear and non-stationary. So then we have to pick, instead of using Wiener, we have to use, maybe you can feed into recursive Wiener, or you can apply Kalman filtering. And if you think that your data is moving from non-Gaussian to Gaussian, sorry, Gaussian to non-Gaussian, then definitely you have to pick extended or unscented Kalman filtering. And if you think that your data is highly non-Gaussian, highly nonlinear, then you have to use particle filtering. So this is the Bayesian sets of filtering, where you can think which one will be applicable for your application. And there are some approaches that is called blind separation problem. It's a kind of solving the cocktail party problem. And there are several blind source separation technique. One might be very widely used approach. This is principal component analysis, and another is independent component analysis. And there are some extended version of those application, and there are some updated version of those algorithm that might be multi-scale principal component analysis, or multi-domain, multi-scale principal component analysis, or you can use multi-scale correlation analysis. So these are the blind source separation technique. And you can also apply spectrotemporal analysis instead of using temporal domain. Instead of using spectral domain, you can apply both spectrotemporal analysis technique. The most common one is short-term Fourier transform, or you can use other version that might be wavelet, and there are a couple of versions of wavelet transform. You can use complex wavelet transform based on your application. You can use dual tree complex wavelet transform. And these are the spectrotemporal analysis. And if you think about data-driven approach, if you think about nonlinear approach, then definitely you have to use nonlinear data-driven empirical technique. That might be empirical mode decomposition technique, that might be ensemble empirical mode decomposition technique, that might be variational mode decomposition technique. So these are the nonlinear data-driven approach. And these are the nonlinear data-driven hybrid model. If you think that your data is highly complicated, highly corrupted, highly noisy, then definitely a single listed approach will fail to denoise to your problems. So for those cases, you have to use some hybrid approach, or you might have to have some multi-stage approach and multi-stage decomposition. And for those highly complicated problem, you have to pick a hybrid model based on your problem. You have to select some hybrid approach. So yeah, so these are the advanced techniques, advanced signal processing approaches that can be applied, but there is no rules or theorems that which one will be suitable for what. That will based on your expertise, your experience on signal processing and data analysis. Then this is you who have to select which approach will be applicable for what application. So yeah. So yeah, so I can recap the few slides what I have told last 6-7 slides. I try to cover the application of signal processing. It's very diverse. And I talk about the workflow of biosignal processing, especially in the healthcare. And then I talk about challenges of biosignal processing. And then to solve those problems, to solve those challenges, we can use some state-of-the-art techniques to biosignal processing. So up to now, do you have any question? I didn't get any response from you guys. So do you have any questions or any suggestion in your head or anything that you'd like to share with me? Are you there?
No, sir, no problem.
Okay, okay, thank you. Okay, if not, then I can go the next slide. So I have talked about the signal processing approaches, classical approaches, and I talk about the challenges that we faced in biosignal processing. I have talked about the state-of-the-art technique that can be applied. to solve our problem. So now come to the point how we can solve. Like, yes, we make a model, we build a model, and we know how to learn from the data. We know we know the data, we know the algorithm, but we need a computing platform where we can make this model. So if we think about computing platform, there are two widely used computing platform for signal processing and machine learning. If you think about signal processing and machine learning point of view, Matlab is a widely used tool. But the problem is that that's not free. You have to buy. And second one is Python. Python is an object-oriented programming that is vastly used in machine learning, deep learning, and signal processing. And if you compare Matlab and Python in terms of easy to implement, definitely Matlab is easy to implement, but Python is free. Python is open source. And if you think about hardware platform, Python is much more easier than Matlab to plug in the hardware. So if you think that point of view, Python is a very good tool to work on. And another strong point of Python is that sometimes in Matlab you can use some block, or you can write in the code. And if you use Matlab function, sometimes you have to use as a block or use as a function, but you don't know what is going inside in the Matlab function, because Matlab is a commercial software they will not allow you to edit their code. But on the other hand, in Python, it's open source. If you want to edit the function, if you want to have a look on the function, how the function is working, you have that option to revise and edit those code. So if you think about research point of view, if you think about hardware implementation, Python is definitely it's a good choice. Okay, so today I'll talk bit about Python. So before going to that, I need to know how many of you are familiar with Python. Can you write in the comment box, like if you are familiar with Python? Like it will be easy for me to get an idea about your status. Like I don't know, like are you expert in Python? Are you like a beginner level, or like what is your current level? You can just write in the chat box. Like let's say if you write type 1, it means you know something about Python. If you type 0, I will understand that okay, you guys don't have knowledge about Python. Can you use your chat box? Yes. Okay. Oh, that's good. Hmm. Okay. Got it. So it seems that 30% maximum you know Python, and rest 30%, not 30%, more than 60%, you don't have much knowledge on Python. So okay. Got it. Okay. So in today's session, basically I made 2 slides based on your status. If I found that most of you guys are not familiar with Python, then definitely I have to use the beginner one. And from your response, most of the 19 cities, they don't have the Python, and most of the other cities also, they are not much expert on that. So in today's session, I'm going to presenting the very beginner level one. So yeah, and that might be a bit boring for those who have already know Python advanced level or expert level, but it will be good for the beginners. Otherwise, it will be really hard for me to sync all of you guys. So I have to decide one. So I will start the beginners one, and then last couple of minutes I can give you a rough idea about some advanced topics or research-oriented topic where you can apply Python, and where you can use the advanced knowledge or advanced packages in Python. So okay, so I will start how you can download Python. As I told earlier, Python is a open source. That means you can download, and there is a multiple way you can download, and there's a multiple Python ID. So, but if you talk about the easiest one, then definitely Anaconda will be the easiest way to use Python. So I can share. You can go this link, www.anaconda.com, or I can share my link. So I can share another screen. Yeah, not this one. Yep. Stop sharing, and I can share this one. Yep. Yeah, hopefully you can share. You can watch my window. So if you go that link, then you will go the Anaconda website. So in Anaconda website, you can simply go down, and you will find Anaconda installer. So if you are using Windows machine, then you have to go Windows, and you have to download based on 60-bit or 32-bit machine. And if you're using Mac, then you can use anyone from this. And if you are, tech guy who love to live free, then Linux is fine. You can download it. And the good thing is that you can use interactive a module that is called Jupyter Notebook. It's very interactive, especially for the beginners. I always push the beginners to use Jupyter Notebook, something like this. It's a notebook and cell-based approach. When you download the Anaconda and install it, then you can open the Spider as an ID, or you can use the Jupyter Notebook. It will open in your browser. Like if you're using Google Chrome or Mozilla Firefox, then it will be go directly to the your browser, and you will have a window like this. This is Jupyter Notebook, where you can write lots of like write your code, and you can debug it, you can run it. And if you have very long code, like a very big line of codes, then you also use a notebook. That is much easier to find out the problem in your find out the problem of your code. So yeah, this is the way where we can download and install. And either we can use an ID called Spider ID, or any other PyCharm, lots of IDs, or you can use the online version. This is the Jupyter Notebook. And at this moment, if you don't have installed, I will not suggest you to install at this moment, because it will take at least 10 to 20 minutes. So that is a waste of time. So at this moment, you can go Google Colab. Google Colab it's a virtual platform. In this platform, you can use the Python virtually without installing Python. So it's a very nice platform. So I can write this in the comment box. How is that? Yeah, the chat box. So this is the Google Colab. You can go there and you can write the Matlab, the Python code. If you don't have Python installed in your machine. So yeah. So I do believe you know how to download Anaconda and install it. And at this moment, you can use Google Colab. And after finishing this session, if you're interested, then you can download and you can install Python. So now I will talk about. So now I come back to the slide. Okay. Okay. Yeah. So this is the first thing about Python. Python is close, similar to Matlab, but not exactly similar. So, and there is two versions in Python. One is version 2, Python 2 and Python 3. Python 2 is legacy, like this is the first version, and Python 3 is called present and future. So, yeah, and this is the, like, when you have the Jupyter notebook or any ID, then first thing we need to know how we can make a comment. Like we write a code, and for writing any interactive code, it will be much more easier if you write the comment, if you write the description about your code. So if you want to make a comment, then you have to use this is called ampersand, or what the sign is called, I forget it. I think this is the like for single line comment you can use this one. This is on one line comment, and if you want to comment multiple line, then you have to use in this way, 3 dot. Yeah, and then this is the option where you can comment a single line or a multiple line. And I will give you a very brief overview, and then I will go the Jupyter notebook and where I will write the code, and I think that will be much more easier to have a look on that. So, but just couple of minutes, I will give you a very brief overview about this coding, and then I will.
Sir, slide is not visible.
Oh, really?
Yes, sir.
Oh.
না স্লাইড তো দেখা যাচ্ছে তো
We can see the slide.
Okay, but some of you.
Sir, I also can't see, sir.
You can't see. Okay, then I can stop share, and then I can reshare again. How is now?
Yes, sir. Now we are.
Now is it visible to all?
Yes, sir.
Yes, sir.
Okay. Thank you.
Yes, sir. We can see.
Yeah, thank you. So I will just briefly talk about these slides, and then I will directly jump to the notebook. I think that will be much easier because it's a coding. It's really hard to explain. Better to write the code instead of explain the code. So, but I will do it shortly. And second thing is data type. Python have a different data type. types of variable. Like if you think about Matlab, we can assign any number or any value in a variable. But in Python, if you assign a variable based on the item, like what you have assigned for a variable, then that will be the type. Let's say if we put x equals to 10, that will be type will be integer. That means x will be an integer type variable. But if you assign, let's say for this one, x equals to 10.5, it will be a float type variable. Okay, so you don't need to be explicitly define the type of variable. Automatically they will know what a variable you are going to handle. And if you want to know the type, like if you want to know the variable type, then there is a command called type. If you type and with a fast bracket, if you write the variable, then this will give you the type of the variable, like what type of variable it is, like is it integer or float or list or something others. And data type, list is a very common data type in Python. In list you can use multiple type of variables. Like if you think about Matlab, in Matlab, if you assign a variable, you have to use the same type of data. But in list in Python, like you can assign integer, you can assign float, you can assign a string. Just for like this one, my list is a Python list, where you can assign a list of different type of variables. And another important thing that you need to keep in mind, normally in Matlab, the indexing starts from 1, but in Python, indexing starts from 0. And in Matlab, if you type like any variable with end, it will give you the last item. In Python, you have to type something variable, third bracket -1. -1 represents the index of the last element. Okay, and tuple. The basic difference between list and tuple is that in tuple type data in Python, if you assign something, you can't change. Like let's say we assign a variable called state, and we put some string like Victoria, New South Wales, Queensland, something like that. And if you want to change the variable, you can't. That means the difference between list and tuple is that once you assign item in tuple, you can't change. But in list, yes, you have an option to change your item. And third one is dictionary. This is similar to list, but the main difference is that you have to have a key value pair. Like in list, we can assign item, and based on the index, we can access the item. But in dictionary type data, we have to assign the k, that means index and the value. And definitely you can change the value. You can change the item. So this is the table how you can understand the difference between list, tuple, and dictionaries. So in list, the indexing start from 0. In tuple, it also start from 0, but the problem is that you can't change the you can't modify the tuple item. Once it's assigned, it's done. You can't change. But for list and dictionary, yes, you have that option to change the items. But the difference between list and dictionary is that in list, the indexing starts from 0 and gradually 1, 2, 3, 4, 5, and blah, blah, blah. But in dictionary, you have to be specific. That means you have to assign the index and the value. Okay, now I think we should better to go to the Jupyter notebook where I can write the code, and then you can have a more clear idea. Okay. So like once you have installed Anaconda, and if you open the Jupyter notebook, you will get something like this. So this is a file. We can open a new Python file, so it will get like this. Okay, so I
Sir,
hope you
we
guys.
we cannot see the screen of Jupyter.
Oh,
Still, it shows the presentation slide.
okay, okay. But I don't know why it shows like this. Let's see.
Please share your desktop share.
Yep,
Like-
I did it. I did it. How about now?
Yes, sir. Now we can see the Jupyter.
Okay, thank you. So once you open the Jupyter notebook, you will get something platform like that. Okay, so in your first slide, I told you how to make a one-line comment. Like let's say, this is IICT workshop. Okay, and we want to make a comment. Then simply we have to type like this, and if you run this, so Jupyter will consider it as a comment. Okay, and if you write something, a is a variable, let's say x is a variable, we can type 10, and y is a variable, we can assign 10.5, and if we print is a function to print something. Okay, if we print x, y, and if you run it, that means using the print function, we can print the value that is assigned in x and y. And we have also learned the function called type. So we know type function. Type will tell you the type of the variable. So if you print like this, we print this, and let's say, yeah. So x is 10, and the type of x is integer, like it's integer class. Y is also variable, but where we assign 10.5, 10.5 is not integer. So y is a class of float type. So yeah, so, and if we make a multiple comment, like multiple comment, yeah. So this is example of multiple comment, where we can comment more than one line. Okay, if you run this, look, that means both of these are not included in your code. Okay, so you can use this one for single line comment. You can use this 3 comma 6 comma. It will be anything inside this 3 dot. It will be considered as a comment box comment. And yeah. So now we will talk about the data type. That means we talk about list. We already know the data type called tuple. We already know the data type called dictionary. So now have a look on that list. So we learn list function. Okay, list function. So what is list? As I told earlier, let's say assign a variable my underscore list. This is a variable where we will assign something like this: 1, 2, 3, then IICT, then float point 5. Yep. And if we print it, my underscore list, have a look on that. That means list is a variable where we can assign different type of data. It may be string, it may be integer, it may be float, even it might be complex number. So if you assign something like this, 4 plus 5j, this is a complex number that also can be assigned in a list. Okay, so this is the list type of data. And let's say we need to know the item in a list. So if I want to know what is the first item of my list, or what is the last item of my list, how can we access those information? As I told earlier, the difference between MATLAB and Python is that in MATLAB, the index start from 1, like 1 means the first item, and then 2 means second item, 3 means third item. But in Python, the first item, the index of the first item is 0, second item is 1, and so on and so forth. So if you want to access the first element of my list, if we print my list with index 0. Index 0 means it will give us the first item in my list. If we run it, so have a look on that. 1 is the first item that is assigned in my list. So the index is start from 0. So, and if we print if you want to know the third item, 0, 1, 2, 3. 1, 2, the third items, it will be 2. You will get the third item. If you want to get the fourth item, it will be something like this. So this is the indexing. And another good thing is that if you want to access the last item, you can put simply -1. If you put my list -1, that means this is your my list, and you assign these numbers. So my list -1, that means you will get access this one. So if you print, then you will get like this. Like this is 0, 1, 2, 3, 4, 5. Or you can say -1, -2, -3, -4, -5, -6. So if we put like this, you will get -6. This is -1, -2, -3, -4, -5, -6. So you will get the same value. Have a look on that. So from the left side, the index is start from 0 and gradually it will increase. And the last element is called -1 index. And you can count reverse way, -1, -2, -3, -4 like that. So this is the indexing. And slicing. Slicing means if you want to get access of some portion of the data. So should it work? Yeah. Slicing means this is start and this is stop. That means I am requesting notebook to print my list, the item that from index 0 to start, stop, not this one, up to that one, like 0, 1, 2. This is something like this. So start, then increment, then stop. But this will not be not included. Okay, so this is the slicing approach. Like when you need to slice the list data, we can slice in that way. We can put the starting index from where it will get access the data, and then we can put some increment. If you don't put anything, it will take 1 as a default increment, and stop up to when you have to stop. But you have to keep in mind the stop index will not be included. Let's say if you say 0 to 3, the third will up to third, not included third. Okay, so this is the, I think, yep, I try to cover the Python data type called list, and then tuple. So better to copy this to save my time. Yeah, what is tuple? As I told earlier,
Sir, tuple is same kind of list, but it cannot be changed when it is derived.
Yes, like, oh, just let's say in my list, okay, in my list, if we put the index 0 equals to, let's say, value has changed, okay, and print my list, and after my list, have a look on that. Look, this is the initial value of my list, but I changed the 0 index. In 0 index, the first item was 1, but I changed the value 1 with item called value has changed. So I changed item 1 with a string. That means list is modifiable. Like once you assign a list, you can change any item. But in tuple, once you assign, you can't. Did you get my point? Are you clear?
Yes, sir.
Okay, thank you. So now, oh, sorry. Just simply I can copy from my previous one, so it will be good. It will save my time. Okay. Okay, so have a look on that. So in tuple, let's say we assign a tuple called my tuple. And another important thing is that list assignment start from third bracket. Have a look on that. This is third bracket. This is ending with third bracket. Like when you assign a list, it will start with third bracket, end with closing with third bracket. But when we assign a tuple, it will start first bracket and end with the first bracket. So if you find something with first bracket, that means it's a tuple. That means it's a tuple. And that means you can't modify the item once you assign. So have a look on that. This is the my tuple. I assign 4 string called Meherpur, Rajshahi, Dhaka, Chittagong. 5 string I have assigned in tuple called my tuple. And if we print it, let's say, if we print it, that means it shows that this is the value that have been assigned, and there is a function called len to understand the length of the tuple or length of the list. Anything assigned in a list or tuple, you can use len function, len, that is called, I can write it to make it clear. This is len to know the length of the list or tuple or any other variables. Okay, so if you run it, it shows the my list. Sorry, it should be my tuple. My tuple, the length of my tuple is 4. That means 1, 2, 1, 2, 3, 4. That we assign 4 string in my tuple. Okay, and I told you earlier that the difference between my tuple and like tuple and list is that you can change the list, but you can't change the tuple. So just for example, have a look on that. This is the my list that I assigned in the earlier cell, and I can easily change the item. And this is the and this is the tuple that is already assigned. The 0 index is Meherpur. If I want to replace the Meherpur with Khulna, I can't, because the first thing of tuple is that you assign tuple, you can't change, you can't move. So if we force tuple to modify its value, it will show error. Have a look on that. Look, so my list was value has changed 2, 3, 4, and then again I change the value. Now it's the change the value. But when I change the value or item in the tuple, the first value of the tuple was Mirpur, and I try to replace it with another string called Khulna, and it shows tuple object does not support item assignment. That means you can't like modify or assign tuple. Once it is made, it's done. You can't change it. Okay. So this is the tuple. Now I will discuss about another data type called dictionaries. So yeah. So what is dictionary? Dictionary is similar to list, but similar in the sense in tuple you can change, but in list, in dictionary you can change the value by changing the case. But the difference between list and tuple is that in list the indexing is start from 0, 1, 2, 3, 4, something like that. But in in list, yes, in dictionary we have to assign the value and the index. Is it clear? Like let's say
Yes, sir.
we declare our dictionary with third bracket. Like if we assign something with third bracket, sorry, curly bracket, I think it's called second bracket, curly bracket, it will consider as a dictionary. Once you declare a dictionary, then this is the index. My dictionary, I assign a dictionary, and this is the index, and this is the item, or this is the value, and this is the second index, and this is the value. So in list, the index is always integer. You can't string, you can't float, you can't use float, you can use string as a index. No, you can't. But in dictionary, you have that option. If you want to use string as your index, okay, do it. If you want to use float as a index, you can do it. If you want to use as an integer, fine, you can do it. So this is the main difference between list and dictionary. So this is the strength of dictionary. Like sometimes we have to handle both, like let's say text data and categorical data. Sometimes we have to handle it, like if we think about solving a practical problem, then you have to have a multi-dimensional data. Some data may be categorical, some data might be text, string, so streaming of the data. So based on those cases, definitely dictionary will give you extra advantages rather than using the list. Yes, you can do the same thing using list, but if you use dictionary, that will be much more helpful. Okay, so so I declare my dictionary as a dictionary. This is the index. I use a string as index, and this is the integer second as index, and I can put, yeah. So if we print this, it will shows, like, let's have a look on that. If we think about my list, I can go the my list. Okay, then it will be more easy to make sense. Print my underscore list. Okay, this is my list. Have a look on that. There is no indexing, because the indexing starts from 0, 1, 2, 3, 4, 5, or -1. But when you print the dictionary, then list only shows you the item or the data, not the index, because index is constant, 0 to -1. But in dictionary, it will show the index and the value, index and the value. Okay, so if we print the first item, then you have to, like, if we want to print the first item in the list, something like this, print, how can I do it? I can like simply like this, print my list. What is the first item? It will be 0. Okay, But if we want to print the dictionaries, dictionaries, DICT, and it will be third bracket. If we put 0, it will not work. Look, you can get access the list, but dictionary you have to assign the index, because for dictionary the index doesn't start from 0. You have to know the index. What is the index of the first item? Go the main text. So this is your first item, and the index of your first item was 1. So you have to write this one. Then it will work like this. And if you want to get access the second item, then you have to put the second index. What is the second index? This is 2. If we 10 like 10, second index means the index for second item. So this is the second item, and the index for second item is 10. So you have to put like this, 10. Then you will get the second item from the dictionaries. So this is the basic difference between list and dictionaries. What is that? In list, the indexing start from 0 to 0, and then gradually it will be increment 1, 2, 3, 4, 5, something like that, and the end one will be considered as a -1. But on the other hand, if you think about dictionaries, you have to assign item and the index, and if you want to get access the item, then you have to put the corresponding index of those items. I hope you understand. So yeah, so up to now I try to cover variables, how you can declare the variables. So I write down variable, how you can declare, and how do you know this variable? Use the type function. If you type something, type, then you'll get it will give you the type of the variables, and then we learn 3 different types of data type. One is list, one is tuple, one is dictionary, and we know the difference. List is start using like this, third bracket. Tuple is using first bracket. Dictionary, third bracket. If you have second bracket, it will be dictionary. If you get the first bracket, it will be tuple. If it is third bracket, it will be list. Okay, and the difference is list indexing start from 0, tuple also 0. For dictionaries, it will start from some, you have to assign the index. And another difference is that list and dictionary, you can change the item. Okay, let's say in the dictionary we have the first item was, this is 1, but we can change it, like the first item was this is 2. You can write this is not 1. Okay, and if you print like this, okay, and you print like this, initially it was 1, but you change the index with some other item. This is not 1. That means in tuple, I just make it confusing. In dictionary, yes, you can change the item. In list, you can change the item. In tuple, you can't. And in list, indexing start from 0, tuple start from 0, and dictionary, it is you have to assign the index. So up to now, do you have any questions or any confusion?
No, sir.
I just always listening the one voice. What about the others? All good? Okay, I do believe everything is fine and going smoothly. Okay. So now I will go some bit other packages that need to use. So again, I will start. I will pause. Okay, I will resume my slide. Where is my slide? That should be there. Okay. Yeah, I hope you can watch my slide if everything is fine. Okay, there is okay. So there is branching, like we did slicing, I think. I hope, yes, we did slicing. No. And then branching, okay. And then there should be loop, yes, iteration, for loop, while loop. And there should be okay. And Python module. Okay, what is Python modular package? So up to now, what we have talked, that is very basic about Python. We try to understand how we can assign variable, how we can assign different type of data, like it might be list, it might be tuple, it might be dictionaries, and then come to the modular package. What is module? Module is a single Python file, and package is a collection of multiple module that is assigned to solve a big problem, some bigger prospect. Okay, so there are more than, I think, 200K mod packages in Python and modules, and among them 4 or 5 modules are widely used. One of them is Numpy. What is Numpy? Numpy is a package, a Python package that is mainly assigned for numerical computing, and that is very similar to Matlab. If you guys are using Matlab vastly and you want to switch from Matlab to Python, I always suggest you use Numpy, because Numpy, it works similar to Python, Matlab, like assigning variable, slicing variable, accessing variable, removing and adding variable is quite similar to Matlab. So if if we move from Matlab to Python, sometimes it might be confusing, because sometimes when you write the code, you can get confused with Matlab, like, you know, Matlab syntax. Like for me, somehow I vastly use Matlab and Python. Sometimes when I switch from Matlab to Python, I write, you know, the Matlab syntax. So if that is the case, then you can use NumPy. It will make your life much easier. And SciPy, this is mainly for engineering one, like signal. You will get lots of signal processing packages, modules, signal processing tools, machine learning, not machine learning, signal processing, mathematics, and statistical tools, SciPy. And another is Pandas. Pandas is for tabular data. Like if you have to handle the tabular data, like you have stored data in the Excel or CSV file, if we collect the data in our variables, especially for the variable data, let's say your wristband, let's say it might be your mobile phone or any kind of gadget, it stores the data in the tabular format. And if you want to access those data, and if you want to analyze those data, then Panda is a fantastic package to access those data. And Matplotlib. Matplotlib is a package for mainly for graphics. Like if you want to plot something, if you want to any kind of graphical representation, any kind of graphical visualization or data exploration, like mainly for data exploration. If you think about signal processing or machine learning point of view, we need to explore the data, we need to analyze the data, we need to visualize the data as much as possible. Okay, to understand the pattern, to understand the, you know, the features from the signal, from the data, we need to visualize. So for those cases, Matplotlib is a very fantastic platform. And second one is machine learning and deep learning. As you know, today's life is it's a hot cake. It's a big cake, and it's widely used in different applications, from electrical, computer science, statistics, medical. So machine learning and deep learning is everywhere. So for those, there's lots of packages, lots of tools. It might be Keras, Theano, TensorFlow, PyTorch, and Nets. So there are a couple of good packages, and basically I'm used to use PyTorch. I know PyTorch, TensorFlow, and Keras, but you can use anyone from this platform. If you need to make a machine learning model or deep learning model, then you can pick anyone from this package for that is machine learning or deep learning module. Okay, so this is the this is the sets of package or module that is widely used in Python for different application. Among them, as I told, Numpy, SciPy, Pandas, Matplotlib, and a group of libraries that can be used for machine learning, that can solve your machine learning problem or deep learning problem. So yeah, so then again I have to go to the Jupyter notebook. We do some hands-on practice. So stop sharing and share screen. Can you see my Chrome? Can anyone reply? Is it visible to you?
Yes, sir.
Yeah, thank you.
Yes, sir.
Thank you. So we told earlier, we give some brief overview about basic Python data type variables, and we also learn few function like type to know the type of a variable. We learn the function called len to understand the length of a function. We know how to make comment. We know how to assign data in a list. We know how to assign data in a dictionary. We know how to assign data in tuple. Now we'll briefly talk about these packages. Let's say Numpy. As you know, Numpy is mainly for numerical computing. Okay, then like why we have to use Numpy rather than a conventional list or tuple or dictionaries? Because Numpy will make your algorithm faster. Numpy will help you to write the code smoothly. Okay, so just have a look on that. This is a variable x where we assign 5 integer, that is 5, 10, 15, 20, 25, and y is another variable where we would like to store the quotient divided by 5. If we divide 5 by 5, we'll get 1. If we divide 10 by 5, we'll get 2. If we divide 15 by 5, we'll get 3. So we want to write a code that will store the quotient divided by 5, and now x is a list, and if we want to do this, then we have to use like this. We use a for loop. Okay, so I think before that I should better to introduce you how to write the for loop. Yep. It will be much easy otherwise. Anyway, I can tell you now. So for loop is we how you can write the for loop. The syntax for for loop is that we have to for assign a variable in x. X means 5, 10, 15, 20, 25. So the counter, the value, the variable counter will pick the is value from the list x. So first item will be 5. 5 by 5, it will be 1. Then again the for loop will work for next iteration. It will pick the value 10. So when you divide by 5, it will be 2. So if you run this code, look. So this is the your original list x, where you assign these values, and y is another variable where we keep the quotient divided by 5. Okay. To do this, we need to write a for loop. We need to write a function called append. So we learn here. We have to use for loop. And we use a function called append. Append means it will be stored one by one. So y is a variable. It will be stored first quotient, then second iteration it will store the second quotient, third iteration it will store the third quotient. That means if we want to make this job done using the list, I need to use for loop. I need to use a function called append. Then it can be done. Okay. If we use normal list, but the same thing we can do using a single line in Numpy. What is that? Let's say if you type like this, y is a list where we want this one, x by 5, it will give you error. You can't access the list item in that way. Okay, and that's why we have to write this code. Okay, but if we assign, let's say x2 equals to numpy array. So before that we have to import the numpy. What is import? Import means if you want to use any module, any package, then you have to import that package in your workspace. So import numpy as numpy. That means in your work you want to use numpy package. That's why you import that numpy package. Numpy is already stored in your device, in your machine, but when you want to use numpy, you have to import numpy, and that's why we write a single line code: import numpy as a np, and then numpy array x. What is x? X was a list. Now we convert the list into numpy array, because when you use the numpy package, we will convert everything into numpy domain. And now x2 is a same data that is stored in the x. And if we do the same thing, have a look on that. Yes, it works. And if we print it, print y, look, we get the same thing. We get the same quotient using a single line, y equals to x2 by 5. But to do the same thing in the conventional list, you have to use for loop, you have to use append function. That means it will make your life bulky. It will make your code bulky. Okay, so that is not super efficient. Yes, you can make it done, but if you think about efficiency, definitely Numpy is much more efficient than conventional list. Is it clear to you guys?
Yes, sir.
Okay, thank you. So this is why we have to use packages to make our code faster, to make our life easier, and to solve the big problem with efficient way. And again, if you want to use any packages, before using those packages, you have to use you have to import those packets by using the import function. So we can write it here: we need to use any package, you have to import before using, what is that? This is called import function. This is the import function, and we want to numpy, and to make the code short, we use numpy as a np. Okay, but if you don't like to use np, then you have to simply write like this, the full numpy. Okay.
Sir, using NumPy module, why we cannot see the floating numbers in the print while we print? Just like, sir, just we saw 1 point, 2 point, but in the previous we saw that 1.0, 2.0.
Okay, like this is the when you divide, it will consider the quotient y as a floating point. So if we just have a look on that, if we put the value 5 point, let's say 26, okay, 26, then it will be clear. Have you got it? So NumPy normally don't put the 0 until it has a value. Like 1.0 and 1 is same.
Okay, sir.
Got my
Thank
point?
you, sir. Yes, sir.
But there is two different domain in the sense, like let's say you write a code in your way and I will write my code in my way. Both code will be accurate, both code will give you the same output, but the pattern of the code will be different. So NumPy is a package that is written by, let's say, by you, very smart guy, efficient guy like you. So that is like that way. And let's say the conventional list is written by me, that is not math efficient like you. So there should be like the value will be same, but the style will be different. Okay. So normally NumPy don't put unless it has a value, like let's say for 5.2, it shows the 5.2. Okay. Yeah.
Okay, sir.
Then there is some function in NumPy, like we can assign a 0 by 0 matrix. Like let's say in your calculation, in a computation, you need to assign a matrix or a variable like 3 by 3 or 4 by 4 or anything. Then you can use like 0 matrix or identity matrix. Sometimes, you know, for signal decomposition, we need to have some that type of matrix. Then you can easily do like this. If you write numpy.zeros 3 by 3, it will make a 3 by 3 array, and all the element of this array will be 0. Okay. And if you want to write something arrange, it's a function that will excuse me, that will assign all the value from 0 to 20, not include 20. Okay. And this is a and the style is that if you use NumPy arrange is a function, it will create a array, and the syntax is that you have to write like this: start, stop, and increment. If we use NumPy arrange package, it should be like this: np dot arrange 0, start, stop, and increment. Okay. So if or it might be if you don't have any value like np dot arrange, if you have only one argument in the sense input like this, it will be only stop. If you put one argument, sorry, Yeah. So if you write numpy arrays, so it will put the start 0 as a default value. If you don't, if you omit start, it will take 0 as a default index. And if you don't assign any increment, it will pick 1 as a increment and stop as a stop. For this code, have a look on that. We assign numpy dot arrays 20. That means there is only one argument. So where is the start? Where is increment? That means 20 is the stop item, and what will be the 20 is the stop item, and what will be the start? The start should be 0, and what will be the increment? Increment will be 1. And this is but we can do the same thing. Let's say b1 start stop. This is the same thing. But if you only put 20, that means NumPy already know that, okay, the start is 0 and increment is 1. And for this one, this is the start from 0, stop at 5, and from the 0 to 5, increment 0.1 increment. So if you run this code, have a look on that. I think we can highlight, comment this. We also comment this one. Yeah. So yeah, from start the same is 0 to 20, but 20 will not be included after 20, and the increment was 1. And for this one, B1, you assign the start stop. This is the normal approach, but this is the efficient approach. Okay, and then yeah, another example, 0 to 5, 0.1 increment, so 0, 0.1, 0.2, 0.3 up to 5. Okay, so this is the range function in NumPy, and another one is zeros function in NumPy. Like if we put something zeros with a fast bracket, the shape of the matrix or array, this is 3 by 3. That means you are assigning 3 by 3 array a variable called a, and the item of those array will be 0. All the item will be 0. If we run this command, it will be 3 by 3 array, and the array is like that. And if you want to access the value from the array, you can put like simply print a like let's say 0 by 0, first row, first column. As I told earlier, NumPy will be similar to Matlab. So first row, first column, it will be 0. It will be 0. Okay. And yeah. So this is the very basic about, I know NumPy is a very big package. I just give you a very beginner level idea about NumPy. And the second one is the matplotlib. So matplotlib is mainly for plotting your data to better visualization. So, and if you want to use matplotlib, then you have to write a command like import matplot pyplot plt. There is some other functions that if you don't use the like if you bring all the matplotlib, that means it will be, if your processor is not very big on, then it might slow your machine. So instead of using whole matplotlib, we can use some specific function from the matplotlib. Okay, then we can write like this: import matplotlib from pyplot. Actually, we are trying to use pyplot, but pyplot is under the umbrella of matplotlib. If we import only matplotlib, it will import everything under the umbrella of matplotlib. That means you are trying to fetch all the module in the matplotlib. So that will definitely make your system slow. But if you want to a specific module from a package, let's say we want to use pyplot, only the plotting function, then we can use like, okay, the plotting function is under the umbrella of matplotlib. So we want our system efficient. We don't need to use all the matplotlib. We can simply pick the pyplotlib, only pyplotlib. So this is import matplotlib pyplot. Okay, that means we are not importing whole matplotlib. We are simply importing pyplot, and then this is the pyplot. Now the PLT will be work as a simple plot in MATLAB. Sometimes if you plot in MATLAB, plot something x, y, and something like that, then it will give you a plot of x or y. The similar thing we can do using MATLAB, that is called pyplot module. So we import the pyplot module, and we assign a value like some point, let's say x, in time domain, like number of samples. You can say a not t, and y is a graph. We want to plot a sine function, and then y2 is another function, or cost function, and lean space is a function. So from this we learn pyplot, that under the umbrella of matplotlib, that is solely used for plotting a function or graph. And then we learn lean space. What is lean space? Lean space is it will making it's quite similar to a range function in Numpy, but in range function we have a start stop increment, and here it is like this. It will be start lean space np dot lean space start comma stop and number of points that you need. Okay, so I want 100 points, and that point start from 0 to 20. This is my t value, and I want to plot and this is my function y. Y is nothing but a sine t, and y2 is nothing but a cos t, and we want to plot. If you want to plot in the MATLAB, what should we do? We simply write a plot function. Plot t into y1, that's it. Plot t into y2. The same thing we can do it for plotting. We use the pyplot, and this is the short form. We use PLT. So this is PLT dot plot. So this is PLT dot plot t y, and this is a marker. We want a green colored line, and label you can write sine. You can write something sine function. You can write cosine function, and this is for legend. If you want to write something like and that legend should be and you have to assign the location. Okay, upper right corner. And we in MATLAB we have the lim function, like we want to assign the limit of a plot, that is y limit or x limit. Same thing we can do in Python also. This is called PLT dot ylim or PLT dot xlim, and PLT dot show. This function will help you to show the plot. So if you run this code, okay, and if you want to have a look on the function, the value of this, then you can like this. Then this is the value of y1 and y2. y1 means sine t, and y2 means cos t. And if we plot this function, look, this is the these are plot. These are label sine function. We colored it as a green, and this is cos function. We colored it as a blue, and we assign that the label should be in the right top corner. So this is upper means upper, and right means right. So this is the location where the label should be there. Okay, if you use upper left, it will be upper left that side. Upper yep. If you lower left, it will be that side. Lower right, that side. So you have that option to optimize the label location, and you have the option to optimize the the color of your plot. You have an option to optimize the you can edit the width of the line, like you can increase, decrease, or you can increase the marker size. So lots of things you can plug and play. Okay, so you can do those things using Matlab pyplot function in matplotlib. Okay, up to now, do you have any question?
Sir, the significance of the line plt.ylim, can you explain, please, sir? Why, sir, last line, sir, below the code.
This one?
Yes, the line before that.
This
Sir,
one?
yes, sir, this
Okay,
line.
okay, thank you. As I told earlier, like y, PLT is a function. Y means y, lim means limit. That means if we plot a figure, then we have to assign the y dimension. Like if we put this is into, have a look on that, the y limit is -5 to -1.5 to +1.5. That means we want the figure plot within this y range. If we put like 5.5 and 5.5, have a look on that, it becomes because the y limit is very high. Normally, to get a clear idea or more clear view of your plot, you have to like adjust the y limit. Like normally the adjusting point is a little bit 1.5 times higher the max value of your limit. It will be more more clear, more visible. Okay, if you plot like this, it's okay, but the limit is like there is very unwanted space. Okay, so it will plot this function within this range. Okay, so this is the we assign the range. It's up to you which range you're gonna plot your figure. Okay, based on your application, based on your figure size, you can assign the limit. Similarly, you can put the x limit. It should be x lim. X lim might be -5. Now it's 0 to 20. So your lower value of x limit is 0. Definitely that should be lower than that, and upper value is 20. So your upper limit should be higher than that. So we can put like 20 to 25. X lim. Yep. If we do like if we make it too high, that will not look good. Have a look on that. Yeah. So you didn't get the real picture. So normally the limit should be bit higher than the value of your plot. Okay, so it will be -5 and it will be 25. That will be perfect one. Or you can do it -2 to 2. Then you will get a more clear 2 or 22. Yeah, this is more vivid, more clear. Yeah, I hope you understand.
Yes, sir.
Thank you.
Sir.
Now the another module. So I told you about Numpy, bit about Numpy, bit about Matplotlib, and there is another package called Panda. Panda mainly for analyzing the data, mainly for tabular data, like if your data is stored in any file, any format like text format or Excel format or CSV format or any web-based platform. Okay, then if you use a Panda package, Panda mainly for accessing the data from different stored platform. Like let's say you store data in TXT format, you store data in the CSV format or Excel format. If you use the Panda, that will be easy for you to get access the data. Otherwise, you have to write a few lines of code. But if you use Panda, it will be very simple to access those data, because ultimately we don't need to waste our time in accessing the data, because we have to analyze the data, we have to analyze the signal. But if we waste our time on how to access the data, that will not be efficient one. So if we use the Panda, that will be easy to access the data. Then we can, work on the data, work on the signal. We can write some code for analyzing the data. We can write code for making a model, learning from the data. Okay. So in Panda, there is lots of function. Now again, if you want any package, definitely have to import that module and import function. So I use import pandas as a PD. That means I am importing the Panda package, Panda module in my workspace. And then this is the PD, means Panda dot read Excel. That means I want to read the Excel file. Okay, I want to read the signal or the value or data in the Excel file. And that's why I'm using read Excel function that is under the umbrella of Panda package, a Panda module. Okay, and this is the address. Address means TD is a Excel file that is I stored some data that is located in my desktop. So you have to give the full path of your data. Okay, and then like now you have the signal or the data that is stored in this TD Excel file. Okay, and then it's up to you what type of operation do you want to do. Any kind of operation you can do, because now you have the data in TD in TD variable. You have the data. Now analyze the data or explore the data, and or have visualize the data. So first of all, we need to have a look on the data. We need to visualize the data. So TD head means the first 5 let's say we have a data with 1000 column. So head will give you the first 5. It's a different value, first 5 row of your data, and you can plot it or you can have a look on that. So if you run this, so TD is a variable. We use Panda read Excel function to read this file, and TD head is it will print the first 5 item. This is the first 5 item. Okay, and this is the column. First column is index of your data. Second one is a date. Third one is a value, and fourth one is a value. So if you want to get access the specific TD means you have the whole data. But when you want to analyze the data, you need to get access the specific row or specific column. So if you want to get the TD column, like data that is stored in this column, then you have to assign okay, I need TD is a variable that have the whole data, but I don't need the whole data. I only need a specific column. Then you have to put the this variable third bracket and assign the column name. It will be column name. If you write the column name inside the variable, it will give all the data that is stored in this column. Okay, so now TD is a variable. TD is a variable that is stored whole data, and this is the column name. So this is the column name. So if you print only this one, print TDC, or index, okay, print index, and yeah, Control X. Better to write down here. So have a look on that. Okay, I can recap it. We analyze we store the data in a variable, and we want to access the specific column, like TD column, index column, and have a look on that. So this is the whole data that is stored in TD variable. This is the TD column. Like we want to get access only this column. Okay, and now we get the index. So this is the index. This is the index. I think I'm out of time. So I can stop now because I have a a content for last. I can continue up to next 10 to 20 hours, but I have to stop now, so I can stop sharing and go to my main slide. Just I will take hardly 1 or 2 minutes. How is my okay? I hope you can see my PPT slide. So just go to the last slide. Yeah, so that's all about very brief overview about Python. So just I need to know, I need to go to the last slide. So yeah, this is my area of research. I'm interested in signal processing and machine learning, and more specifically, I work on biomedical signal processing or biosignal processing, and in terms of application, it's a cardiorespiratory signal analysis for brain mapping. So it's a kind of human brain to cardiorespiratory interaction. I try to understand the brain function using the cardiorespiratory coupling or cardiorespiratory devices. And definitely it's a part of wearable-based cardiorespiratory monitoring. And I have worked on sleep disorder breathing monitoring and detection using the low-cost wearables. And I have experience on detection and monitoring of neurological disorders like Parkinson's and attentional tremors. So this is my my domain of research in terms of application, and my technical area where I love to work, or my kind of I have some advanced you can say knowledge, or you can say expertise, mainly in a nonlinear signal decomposition. But yes, I do some research on and I have some experience on classical signal processing, statistical signal processing, adaptive signal processing. But my PhD was mainly on nonlinear signal decomposition technique and statistical learning, database learning. And I also love to work on statistical machine learning and deep learning. So if you are interested in signal processing, machine learning, or any biomedical domain, or if you want to work if you want to use any signal processing technique in your problem, it might be communication, it might be power system, it might be electronic, whatever it is. If you need to apply signal processing and machine learning technique, and if you need my help, feel free to knock me. You are most welcome, and I'm happy to share my my knowledge, my idea, and I'm always on board in this email. So you can drop an email if you're interested or if you need my help. But this is my domain of work. So, and acknowledgement, I would like to thank my collaborators for who supported my work. And last but not least, the IICT, especially Professor Dr. Masood Rana and Professor Dr. Salim Hossain, sir, for organizing this type of informative workshop. And I do believe it will be very helpful. And if you think about research point of view, or like further like working towards a real life problem, then definitely we need to we have to have a solid knowledge on the computational domain. So yeah, thanks to all. And if you have any question, any query, feel free to ask me.
Thank you, sir, for your info. Thank you, sir, for your such a wonderful discussion. Dear participants, if you have any question, please write it down in the chat box or unmute yourself and ask the speaker. You can speak in Bangla for your ease, but as we're running out of time, please try to do it fast possible.
Yeah. Or if you think that it's too big, then you can drop in my email. I'm happy to reply on email because I'm running late because I'm assigned to finish within 5. This is 5:03. So if it's a short question, please go ahead. Otherwise, you can drop an email.
স্যার শুনতে পাচ্ছেন?
Yeah.
আচ্ছা, ওই যে কোলাব রিসার্চ থেকে যেখানে কোডটা লিখলেন ওই পেজটা একটু কিভাবে ওপেন করে যদি দেখাতেন।
ও আচ্ছা, শিওর।
মানে কোলাবে গিয়ে তারপরে যেখানে কোডগুলো টাইপ করা হলো।
হ্যাঁ, বুঝতে পারছি। আমি আপনি যাচ্ছি ওখানে, আমাকে আগে স্টপ শেয়ার করা লাগবে। ওকে ওকে আপনি কি আমার গুগল কোলাবটা দেখতে পাচ্ছেন?
জি, দেখা যাচ্ছে।
Okay, thank you. So, just you have to copy this link. Let's say আমি একটা উইন্ডোতে এটা পেস্ট করতেছি। So it will bring you to Google Colab, and you have to write a file like new notebook. Then again it will bring you a new notebook. Just wait a couple of seconds. Let's say, okay, write down this is a comment, and A equals to 5, B equals to print, make it short, print A. If you run it, it's a bit slow because it's a parcel platform, so you have to wait. And yeah, got it. I hope you understand.
বাম পাশে স্যার ইনডেক্সটা যে ছিল এর আগে যে 1 2 এই ধরনের, আপনি যখন কোডগুলো লিখেছিলেন স্যার বাম পাশে 1 2 এক ধরনের ইনডেক্সিং ছিল।
হ্যাঁ, সেটা আপনার আমি ওটা লিখেছিলাম জুপিটার নোটবুকে, এটা ভার্চুয়াল কোলাবে না।
ও আচ্ছা, আমি ওই জিনিসটা খুঁজতেছিলাম।
আচ্ছা, সেটা হচ্ছে এইখানে জুপিটার নোটবুক হচ্ছে যখন আপনি কোনো অ্যানাকোন্ডা বা এই ধরনের মডিউল ইনস্টল করবেন পাইথনের জন্য, সেই ক্ষেত্রে আপনাকে একটা প্ল্যাটফর্ম দেবে, আইডি দেবে বা অনলাইন একটা অপশন দেবে। বাট ফর দ্যাট ইউ হ্যাভ টু ইনস্টল দ্য অ্যানাকোন্ডা ইন ইউর সিস্টেম। But if you don't have installed, then you have to use the parcel option. So this is the parcel option. That means you don't have installed in your machine, but you can use Python.
বুঝতে পেরেছি স্যার। ওকে,
এটা আপনার পাইথন ইনস্টল করা নাই, বাট তারপর আপনি ইউজ করতে পারবেন। এটা ভার্চুয়াল মেশিন।
ওকে, থ্যাংক ইউ স্যার।
So do you have any question?
কিছু করতে পারছিলেন? জিকে কালোজি ডেটা আনছি। আনার পরে
আমার মনে হয় we need to stop. So if we don't have any question, then thank you very much, the participants, for your time, and the organizer, who working behind the curtain, especially the student coordinators, and our respected teachers who are organizing this seminar. Thank you all. Thank you very much.
You are most welcome, sir.
Thank you so much, sir. And I think with that, this session ends here. Thank you, our honorable speaker, and all the guests and teachers for your valuable presence. We have the next session on 6 p.m. The topics are CHT, HFSS, and FEKO, and the speaker of the workshop is Dr. Muhammad Khadimul Islam, Florida International University, USA. Hope you all are going to join there. Thanks to each one of you for being presented here. That's all. Goodbye, everyone. Assalamu alaikum.